Designing innovation has more to do with pushing the envelope of what is possible and needed, rather than swimming in the status quo. Design follows function, and the results, well, they can be amazing.
AIRSHIP Technologies Group is a design and manufacture company for unmanned aerial vehicles. What's unique about AIRSHIP, we are building long flight endurance, clean tech propelled drones. When we first started thinking about what we wanted in terms of serving the marketplace for drones, it really wasn't going to be a 4-rotor or 6-rotor or 8-rotor. It was going to be a drone that had a combination of vertical takeoff and landing, so it actually takes off from its physical footprint, and yet it can actually go into full forward motion at about 15 miles per hour to deliver more fixed wing characteristics of flight. The other thing about this aircraft was the propulsion. The propulsion to us was going to be very, very important because we wanted to use clean technology. And so when I talk about clean technology, we're really talking about the use of solar film. And if you think about solar sails on top of your buildings or on top of your houses, that's about 6% to 8% efficient. Here, we're using 28.8% efficient solar film made for the aerospace industry. Very expensive, but you get a lot more value in terms of the value proposition for long flight endurance. So what kind of endurance are we talking about? Well,
for the AIRSHIP StingerMAV, endurance and propulsion are directly linked by energy conversion and weight. Propulsion translates the drone's stored energy into thrust. Because small UAVs have strict weight limits, every bit of power used to spin propellers reduces how long the drone can stay in the air. For the StingerMAV 4.0, we eliminate the weight and mass of 3 of 4 motors and replace the propulsion with a single spinning integrated motor with thrust-generating impeller. Air is drawn in from beneath the drone, compressed and thrust pushed to the sidewall intakes of the right, left, and rear air accelerator bladeless ducts. Vertical takeoff and landing, known as VTOL, occur with all 3 ducts facing downward. Flight rotation around the drone's vertical axes provides for left and right banking. This banking is assured by the drone's internal linear actuator servos that partially spin these ducts to reduce air intake for directional flight control called yaw. For forward flights, air is diverted to the rear articulating duct for full force flights. Pitch occurs by pivoting the rear duct between plus 90 and minus 90 degrees. Flight roll is accomplished by simultaneously enabling rear rudder movement with right and left duct movement. Balancing the drone's weight and power is the aerodynamic opportunity for the StingerMAV's flight innovation.
There's a familiar pattern in reinvention. Rethinking answers to problems lead to a new technology coming along to fill a long-standing need. But as it becomes widely implemented, questions arise over how best to use it and how it may change the rest of the world.